Good morning, everyone. Actually, it is close to afternoon, so let's carry on with the talk. And uh, David started his opening talk was we have the technology, and I'm going to get in more detail about the technology. And at the same time, I couldn't catch Neil. He was very busy during the break. Thanks to Neil because he covered one of the important topic which needed some explanation, and I can just refer to okay whatever Neil said, right? So, moving on, we all know that the unconventionals have a big opportunity all over the world, and shale gas is a big part of it. Now, with the shales, uh, like the first and foremost place where shale gas got prominence is the North America, in especially in United States. And a lot has been discussed before about the Barkens, about the Barnetts, and if we see that there is a huge potential, just to talk in terms of the Bakken, which is about 8 billion barrels of oil equivalent in terms of potential. And as per the IR reports, the technically total recoverable shale gas reserves or resources are about 860 plus TCF. Now, that's a lot of it which needs to be exploited. And, and what has happened is in the late 90s, early 2000s, when the price of everything was going up, and same was with natural gas. That's the time when everyone started looking for resources outside the conventional ones, and shale gas got the prominence. However, in those early times, it was more of a statistical play. And see what happened in those 10 years. This is the images from Google, and that's about North Texas, close to Fort Worth, and this is basically the Barnett area. Okay. When I say statistical play, everyone was drilling well everywhere and trying to extract hydrocarbon. Now, that really means people got a lot of it, they sold, a lot of people become rich. But at the same time, it had a huge environmental impact. And the thing is that when adversity hits, like when the natural gas prices cool down, and it was not possible to just simply drill a well and make it profitable, that's when one started looking for technology. They wanted help. And if we just fast forward 2 years in time, this is one of the image from the Rocky Mountains close by to that area. And if we see, this is about like just about 20 acres of surface location, which is actually draining downhole in the subsurface, covering about 2,400 acres. So that's what happened. Means the technology helped to narrow down, obviously, in terms of the right acreage, how to drill the right wells, and how to produce. And and the understanding that we as an industry gained are actually obviously which is the right acreage, and that's what is the core of shale play that Neil covered. And besides that, find out the sweet spots, and we have to land those wells in the right areas so that we can target those sweet spots, how long the lateral should be. All of these questions needed to be answered before we start drilling the hole in Mother Earth. So besides that, once we have drilled the wells, how do we produce it? How we can optimize the recovery? How we can make the life of those wells enhanced? So those were the decisions which or the questions that needed to be answered, and that's what we learned from our experience in about the shale gas or the shale oil in United States. Now, we all know that there is a huge potential and in Europe, and as per the IA reports, again the technically total recoverable shale gas resource is about 600 plus TCF all over Europe, and obviously Poland and France are on the top of the chart, which Rob covered in the presentation. Now, all shales are not the same. Even though they are shale, they have a lot of variations. And we have already discussed why that happens and what are those factors controlling those variations. And, and that's why we have to make sure that we answer those hard questions before we start exploiting the shale gas or shale oil. Now, how do we do it? Now, this is where the technology comes in play. We need a systematic approach. And this approach, the first step obviously is the evaluation, where we have to identify the right acreage, the core of the shale play. And once we have done that, the next step obviously is find the sweet spots. So that's what we want to achieve in the evaluation stage. And once we have done that, we need to drill the wells which actually hits those sweet spots. But it's just not that. The need of the day is the wells have to be planned and steered in such a way that we always get as much as reservoir contact as possible. And that needs a lot of effort. Now, when it comes to producing from those wells, a lot of activity happens, which is all about the completions of those wells, because producing from shale gas, it's very different than the conventional ones. And that's where we need help of technology to automate the designing process of those completions. And at the same time, we have to ensure that it has the least possible environmental impact. And finally, when we start producing, the need of the day remains is we have to keep on monitoring the well performance, because it is very different in unconventionals, the fluid flow. And that needs to be monitored so that one can actually enhance the life of those wells and get maximum return. So that's what is the systematic approach of evaluation, drilling, completions, and production. And that's what I will touch upon each of those topics in brief. As you see, like now we are trying to cover the whole life cycle, right? And if we go into the evaluation step, and that's about finding the core of the shale play. And Neil has covered in detail, so I'm not going to go through those details anymore. But obviously, even in the unconventionals, one needs to run the petroleum system modeling to determine the right acreage. And it involves the conventional way of interpreting the structural plays, even if it is a flat subsurface, but still we need to interpret that. And besides that, we need to understand all the basin parameters like the kerogen content, your TOCs, your the thermal maturity. So once we have got an understanding of these aspects, the petroleum system model is built. Now, once the petroleum system model is built, it actually has those components that we discussed, like the maturity of the source rock. Again, in terms of the clay mineralogy, where is the possibilities of free gas, where is going to be the possibilities of adsorbed gas, and that's where we combine all of these attributes to find out the core of the shale play or the play chance map. And in simple words, if I see that this is the area which is more mature compared to the others, this is my adsorbed gas, and it's telling me that adsorbed gas is low in this part as well as in this part, and the total gas, if I see here, like this is the area. So we all know, like, it is, if we are trying to produce from the subsurface where adsorbed gas content is high, it will take a lot of fracturing effort, and it's going to flow very slowly. So why we should be going ahead in this, and we should avoid those sorry, this is the adsorbed gas, low amount of adsorbed gas. So this is the area which is our target area. So that's the core of the shale play in this basin. This is Marcellus. Okay, and there has been an SP paper published which I have sourced here, which gives a more detailed analysis of how this kind of work can be done. So there are published information available which can help us understand this source of or the core of the shale play. Okay, so that is helping us reduce the impact on the surface footprint, but at the same time we need to understand what is happening in the subsurface in more detail, and that's where we need to do this detailed wellbore characterization work, where all the mineralogies are analyzed as well as the gas content, where the shales are present, which is the pay zone. Maybe there might be many different zones of shale, but every shale zone may not be having gas, enough accumulation of gas. So those kind of detailed analysis needs to be done, and that's where we identify the main shale pay zones that we need to target. Furthermore, as we all know, like, it doesn't flow naturally in the shales, so it has to be fracked, and that's where the geomechanic aspect also has to be analyzed. Which part of or which shales are more frackable compared to others? When we are doing this kind of analysis, what also is important to understand how the adjacent zones for our target is behaving in terms of frackability, whether they are strong enough to withstand the hydraulic fracking, or they will give away, and as a result of which there will be contamination. If there is an aquifer close by, it can contaminate. So those kind of analysis are also done to, and once we find that there are some problem areas, we can take the necessary decisions to mitigate the risk. Moving on, so that's on the pilot wells or the vertical wells, but again, if we keep on drilling vertical wells everywhere, it's going to have a major impact on environment, and that's where we need to use the seismic attributes along with our well data to understand the variations in the reservoir. Now, the shales, whether the different seismic attributes that responds to the fracturing effects or the stress aspects of the reservoir can be used, like many attributes are there, like the 3D curvature or the anthrax, and once we come out of with those seismic attribute characterization work, we can calibrate it with our well data and finally generate the reservoir quality models or the maps which will tell us where the sweet spot is. Now, once the sweet spots have been identified, that's what we want to target when we come to the drilling stage. Now, drilling, it's like the first aspect of drilling in this unconventionals is we need to address the pad placement. We can't just simply go ahead and drill everywhere. So using the spatial information, we need to decide on the where to place the pads. And then we take in account the drilling targets, and we drill the wells, those horizontal sections, as you are seeing, hitting all the sweet spots. Now, a very simplistic way to look at it is one of the horizontal well is being designed to extract fluids from the sweet spot. And those are the 8 different frac stages which has also been designed on this well. And once the actual frac takes place, this is the pretty much the estimate that we have come out with about our hydraulic fractures, how far it is going to reach from the boreholes. And if we see that that's not good enough, there are other places, and we need to extract that. And it can simply be, we can place a few more laterals and decide in terms of drilling. And if we go ahead, the first thing that we have to think is the multilateral placement optimum? Is it going to drain the reservoir effectively? And that's where the other factors like the geomechanic aspect of the rocks needs to be brought in, and that's what the microseismic is telling us, that the rocks have a preferential way of fracking. It's not going to frack just uniformly everywhere. And that's what we incorporate into our Earth model, and when we simulate, the estimates are telling us that these are the preferred orientations, and that's how we can design our hydraulic fracks. Instead of fracking everywhere, we can optimize and we can drill it further. And that's how we can place our multilaterals in an optimum way to drain the reservoir effectively. So, just as a recap, we have gone through the 2 stages of this evaluation and drilling, and we have managed to answer quite a few important questions that were raised in the beginning. But still, there is some more left to be answered, and that's where the next stages of the systematic approach is going to help us. Now, that's where we move into the completions. As it has been discussed, like producing from the shales is not that easy. It is difficult. The flows, maybe as it always happens, like initially it will be flowing very quickly, but then it just stops. It slows down and sometimes even stops. If the fracks close, there is no way the fluid can flow. So, besides the rock properties which are controlling where the fluid is present and how the rocks are going to break and how it is going to flow, there are other important aspects which needs to be considered, which are the pumping parameters. The gel that we are going to use, how strong that gel is, whether it is going to frack the rocks enough or not. And once we pull in all this information, like the hydraulic fracture models, the microseismic mapping, and finally we grid it up and simulate, what we see is it's a small cartoon which is going to show you that this is the hydraulic fracture model which has been built before, just at the design stage. And what we are seeing is that how the natural fractures are there in that reservoir, which are basically trending like this from the top view. And once we pump in and we frac through that particular stage, how the hydraulic fractures are going to appear in the rocks, how it is going to stimulate the rock. Now, that's all about the design stage. But when the operation is on, when we are actually pumping the fluid into the rocks, this whole aspect of modeling and simulation needs to be done real time, because as we know that the, the fracs are done in stages. So we have to incorporate the knowledge from our first few stages and optimize so that the next frac stages are actually going to return us better. And it's very obvious, like based on the frac jobs, these are the parts of the rock which has been stimulated. However, there is still some part of the rock which we haven't managed to stimulate. So this real-time aspect of pumping, modeling, and simulating helps us to understand the parts of the reservoir that we have managed to drain out and the parts that we are missing. And we can then take the necessary decisions and optimize the operations aspect. Okay, so that's what we are achieving in the completion stage. And the next is the production. And when we come to producing this from these long laterals, it's very different from the conventional ones. There is no boundary flow conditions here. The flow in this kind of, in the shales, are either linear, flowing through the fractures, or bilinear, flowing also across the fractures. So what we need to do is we need to keep on monitoring the production, because the main importance here of the monitoring is if we monitor it better, we will be able to forecast the reserves better. And besides that, what also we can do at this stage is through the monitoring, we can, what we are seeing here is a productivity versus the completion index plot, which is the production engineers use in the unconventionals to identify like which are the candidates for the refrac job, which is basically, if we see here, like in this area we have higher productivity, but the completion index is low. So there is something which is impeding the flow of fluid on those wells, and those are the candidates for refrac, and we should go back and refrac those wells and enhance the production. So coming back, like from the subsurface to the surface aspects, when we incorporate the operational aspects and the geological aspects together, we will be able to take the right decisions to effectively exploit the shale plays. And this systematic approach is going to address throughout the life cycle of these unconventionals. Okay? So that's what I have in my presentation, and thank you for your attention.
Okay, any questions for Manas, please? And if not, let me ask one. Does Schlumberger see a big technology gap anywhere? You know, a real innovation that's still to come, or is it just a matter of incremental progress now, do you think? And please,
Yes, on the technology front, as Neil mentioned, there is still a lot to be understood about because in these unconventionals, there is basically about the migration patterns, something that needs to be understood, about the kerogen porosity that needs to be understood. So that's one aspect which where there is some more technology that is needed to address. And at the same time, when it comes to the operational aspects, more needs to be understood in terms of efficiency of the frac jobs that are being done. So the production aspect, the monitoring and the forecasting, that is still some way to go, and that's also one of the key areas where Schlumberger is focusing right now.
okay, Alex at the back.
Hi, Alex Inkster, Kimmeridge Energy. Looks like Schlumberger have done a considerable amount of work modeling fracture propagation in terms of optimizing drainage. I'm just wondering to what extent you've done research into the maximum extent of fracture propagation in terms of whether the fracture could propagate into shallow aquifers, because clearly it's a concern in governments, and it's something that industry needs to address.
Yeah. So what is so that's a concern, and what Schlumberger is right now working on, and actually in some of the place, like I can't talk about the clients, we don't have any release data available, but what Schlumberger is going for, instead of using a listener well for the microseismic, drill all the way, instead of that, what we are doing is with the shallow wells where geophones are cemented, and using that to listen to the information that we are gathering during the frac jobs. So that's one way we are addressing. We are going for the shallow seismics.
Yeah. First over there, and then. Oh, first. Yeah, just no. Come on, just there. The guy with his hand up is normally sort of a clue, I suppose.
I am Eric Houdneau from the Boston Consulting Group. Manas, I had a question. Do you see this trend that we've seen over the past few years of increasing the number of frac stages per play continuing, or do you see a decrease in the number of frac stage because we will have more efficient frac technologies?
Okay. Actually, the increase or decrease of the frac stage is again one of those economic aspect. But what is happening is, like in the early days, the frac stages were placed very like in a regular pattern, but now that is changing. It's going to be not necessarily regular. It is looking into the accounts of all the dynamics in the subsurface, and as a result of which the frac stages are being planned in real time, and that's what is changing.
Down here, please.
Only 20 or 30% of frac stages are actually successful at the moment. Does Schlumberger have a target for trying to, and a timing for that, to trying to improve this? Can we get 50% in 5 years, or do you have any feeling for that?
Yeah. So absolutely, and that's where a lot of research work has gone in. And at this point of time, like whatever I have shown is, except for the real-time modeling and simulation of the frac jobs, which is at this point of time something patented. The rest of the technology is available commercially. Now, what about that patented work, a lot of research work has been done, and as a result of which, you are absolutely right. So the frac jobs, the failure of the frac jobs are mainly because one is not effective enough to stimulate the rocks, and even if it has stimulated, the fracs are not holding up. They close down more rapidly than what was thought of. So a lot of research work has been done in terms of modeling these frac jobs, as well as generating those pumping fluids, which actually is a patented one at this point of time, which has shown a much more improved in terms of holding the fractures, the hydraulic fractures in place, allowing fluids to flow. And in terms of numbers, like what we know that those numbers are going to be made public, and it will be available for commercially also, either by end of this year or by beginning of next year.
Okay. Bob?
Thank you. We've had several references to core areas and sweet spots during the presentations this morning. I know it's a bit like asking how long is a piece of string, but what percentage of licensed shale acreage would you say is typically core area or sweet spot as opposed to the moose pasture?
What has happened is, again, like with the unconventionals, it hasn't been this petroleum system modeling approach was not a standard approach when we started, but of late this is what people are doing. So at this point of time, like honestly, I don't have a number to tell you like how much it is in terms of percentage, how many people, how many oil companies are actually using that approach, but it is being used. So people have noticed it, that this is one of the important component of understanding the shale plays, and people are using it.
Yeah, please, over there.
Yeah, hi. So I just wanted to know your opinion on, obviously there's been huge advances in technology and modelling. To what extent you think that that's starting to influence the political debate, especially in places like France?
Yeah. Yeah, like Schlumberger always tries to stay away from the political aspects. Yes, absolutely, and that's what we also want to promote is the technology is helping reduce the impact on the environment. And as we saw just now, like once we use the different technology, we can actually very easily reduce the footprints, okay, on surface as well as subsurface. And that's what we are aiming for, and we hope that everyone actually embraces that.
Okay, one more please. Young lady from Statoil.
Thank you. I thought in the back of that I'll ask another sort of generic question about how do you think the oilfield services would adapt towards creating the same North American success in Europe or Asia, for example? How long do you think that would take the model to bring across?
So as David mentioned in the beginning, I can talk from a Schlumberger point of view, which is globally in Schlumberger now there is an unconventional group which is focusing specifically in translating the technology that we found has been working in North America. And again, in North America, the shale plays are all different. Everyone has a different characteristics. And what is happening is the knowledge gained there is being translated in Europe as well as in Latin America as well as in Asia. So these are the areas where we have now like groups are being created to address the unconventionals. And I think I can say like right now in UK we are working closely with Centrica. At the same time, a couple of months back, visited Poland, where people have like E&P companies have a big interest in the unconventionals there, and that's what Schlumberger is doing. Means the groups are in the outside North America. The groups are already there, but maybe not in that big way as it is in North America. But definitely, that's the way forward.
Okay, all done?